In this video we'll see about logic gates. What is logic gate means? Depend upon input it give a decision in outside, that is a logical decision. Maybe input is 1 or more than 1, so we get a decision out of this. That what you call a logic gate. It is electrical circuit which gives a decision. Here we have two types of electrical circuits, analog and digital circuits. What is analog circuit means? This is the analog signal. The information is a continuous information is there, and each and every point it contains some information, and the values of information may be changes between maximum to minimum value. It is oscillating. It look like a sine waveform. This is about analog circuit or analog signal. And what about digital signal? It is representing with pulse, nothing but a square waveform. And whenever a square high we are getting, then we can say this is a true, or switch is on, or you can say that as represent as 1. Suppose if you find down, that means downside, and then we can say 0, we can say it is false, or otherwise it is low. We can say low, 0, no current is flowing, all means 0. High and current is flowing and high potential if they mention, true means that is 1. So in digital communication or digital circuits, the process will be done with two signals only, that is discrete signals, that is 1 and 0. Here continuous information is there. Here there is no continuous information. Up to here one information, after this another information is there. So 1 0 1 0 like that it shows. This is a pulse, and pulse represent 1 bit. One pulse is 1 bit. This is 1 bit and this is another bit. So here in digital communication, and a minimum unit is a bit, either 0 or 1. So here you see it is discrete, having discrete values, either here 1 or 0 only we have. But here it is not like that. Suppose here maximum value plus 10 volt is there. For example, you can take plus 10 volt. Here you can take minus 10 volt. It can be any value between plus 10 to minus 10, including fractions also. But here only two outputs, two values only there, either 1 or 0. That what we call binary. Whatever the operations done with these bits are 0 and 1, that is binary numbers. Those are called Boolean algebra. So Boolean algebra we can call binary. Only two valid logics are there in this. One is true or false. Otherwise you can say this only on the circuit on, circuit off, or high or low, like that we can mention. So here you see, for example, we can take a decimal system. Decimal system is which is having decimal system base 10 we are writing. That is how many numbers are there in the decimal system? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Using these numbers, in any number in the decimal system can be represented. Suppose for example, you can take suppose 252 is there. So that is in decimal number. This is a decimal number. So how we can write? That is this is ones, this is tens, and this is hundreds. So what you can write? 2 into 1 plus, these are tens place now. So 5 into 10 plus 2 into 100. 2 into 100. What do you get? 200 plus 50 plus 2. So what do you get? 252, like this we get. Similarly, if you represent a binary number, binary numbers mean binary number system means which is having only, binary number means which is having only two values. One is 0, other is 1. Suppose, so that means the number should be in either 0 and 1. These numbers only we have to use. Like this in decimal, any number of this 0 to 9, any one you can use here. So suppose you can take 1010 is there. Then what is the value of this? This is 1010 base binary. Then first number here, first is ones and here also ones. Second is tens, hundreds. But here how we are getting? First ones, twos, fours and eights, like that you have to take. binary na. So here decimal means 10. That's why each suppose if you are moving like this, and for each digit how many times increases? 1, 10, 100, 10 times increases. Here binary system, that's why 2 times increases. Here 1, 2s, 4s, 8s, like that we have to take. So then what we can take, first number is 0. 0 into 1 plus. Next 1 is there. And that is in which place? 2's place. So I'll write here 1s, 2s, 4s, 8s. So 2 into 1. That is 2 into 1 into 2. And 2's place over. And 4's place. And 0 into 4 plus. And 1 into 8. So what do you get? 8 plus 0 plus 2 plus 0. What do you get this number? And 10 we get. So in binary number 1010 means in decimal number what is the value? That is 10. That means we can write like this. 1010 binary is equal to here 10 decimal. How to convert a binary number into decimal place means you should apply like this. One more example we'll see. Suppose 1, 1, 1 is there. This is binary number. What is the value in decimal place means? And you know that these are 1s, 2s, 4s. So what you can write here? And 1 into 1s plus 1 into 2s plus 1 into 4s. So what do you get? 4 plus 2 plus 1. Nothing but 7. So this is 7 in decimal place. So 111 in binary number is equal to 7 in decimal number. Like this we can convert. So here important thing, and first place is 1s, second place is 2s, and third place is 4, 16, 32, 64, like that we get. Suppose if you take in decimal places, what we are getting? 1s, 10s, 100s, 1000s, 10,000s, like that we are getting. That is the difference, decimal number and binary number. Why 10, 10 multiplied? Here we are in decimal number system, we have 10 numbers. In binary system we have 2 only. That's why we multiply with 2 for each division. We are moving like this. This how to convert a binary number into decimal number. Now how to convert a decimal number into binary number. Suppose for example, you can take 21 is there. 21, this is the decimal number. How to convert into binary? Divide with 2. If you divide with 2, what you get? 10 we get, and you get a remainder 1. Again divide with 2 until it become less than 2, and you have to do like this. That is what is how many times it goes? 5 times, and remainder is 0. Now divide with 2 and 2 times remainder with 1, and divide with 2, and then what you get? 1 time remainder with 0. Now write the equation, write the value like this. That is 1 0 1 0 1 binary is equal to, and what is that? 21 decimal. If you want to check, you can check that. Just you apply the binary system. This number you can write at a place and try to check that. What is that number? 10101. 10101 binary is equal to what is in decimal number. First, this is 1s, 2s, 4s, 8s and 16s. Now start applying from here. 1 into 1 is there, plus 0 into 2 is there, plus 1 into 4 is there, plus 0 into 8 is there, plus, and 1 into 16 is there. So what do you get? Total value 16 plus 0 plus 4 plus 0 plus 1. 16 plus 4 20, 20 plus 1 21. 21 in decimal number. So here how we are converting and 21 decimal number into binary number. So you can write like this. From here to here you have to write. Don't write from here to there. Okay, like this. Of course here in reverse also you get same number only, but from where to where you have to take? From the beginning to here you have to take 10101. That you have to take. That is binary number which is equal to in decimal value. Both are equal only here. And how to convert decimal into binary? Decimal into binary, and binary into decimal means apply this expansion like. Okay, like this we can solve. Suppose if you want to add two numbers, how to add means you see that suppose 2 and 5 is there. If we are adding 7, we are getting this is a normal decimal number how we are adding. And similarly, if you want to add binary numbers, 0 plus 0, what do you get? 0. And 0 plus 1 or 1 plus 0, you get 1. 1 plus 1, actually you should get 2, na? But here in binary number 0, 1 we are getting. Reason, actually 1 plus 1 is 2, but what is 0, 1 means? 0, 1, 0 means 1, 0 binary is equal to how much? So we know that this is ones and this is twos in binary number. And apply the expansion formula. 1 into 0 plus 1 into 2. What do you get? 2 we get total value. This is 0. 2 plus 0 you get 2 we are getting. Suppose if you want to add 1, 1, 1. For this what do you get? 3 we are getting. In decimal, in binary, you get like this 1, 1. So how it become 3? You see that 1, 1 base binary is equal to first term, and this is in ones, this is in twos. So what you can write? 1 into 1 plus 1 into 2. So what do you get? 2 plus 1. What do you get? 3. So this 1, 1 nothing but, don't call 11. In binary numbers you can call like this only 1, 1. And 1, 1 is 3 in decimal system. So 1, 1 binary is equal to 3 in decimal system. Like this we can add the numbers. Suppose for example you can take 56 plus 27 is there. Then for normal decimal numbers, how to add 6 plus 7, that is 13, 1, and this is a carry which is coming from here to here. 5 plus 2, 7 plus 1, 8, like this we can write. But in the same case, if you want to write here like this, 1, 0 and 0, 1 is there, then how to add 1 and 1 we are getting. This is 2 and this is 1. So suppose if you are adding 1, 1 and 0, 1 like this. 1 plus 1 what you get? 0, 1 we are getting. That 1 you have to write as carry. 1 plus 1 what you get? 0, 1 you get. That you get like this. See that 1, 1 is 3 and 0, 1 is 1. So you get 4. This is nothing but 4 only. Why? Because you see that 100 base binary is equal to, you can convert into decimal. You can convert into decimal. This is ones, twos and fours. So what you can write? 1 into 0 plus 2 into 0 plus 4 into 1. Then you get 4 plus 0 plus 0. What do you get? 4 we are getting. So once it crosses the 10, then you get carry here. If it become 2, then you get carry here. Okay, other example we'll see, and here that 1, 1, 1 and 0, 1, 1. Suppose you can take like this. This is the number we want to add. Then what do you get? 1, 1 carry. 1, 1 nothing but 0, 1 here. 0, 1. 1, 1, 1 nothing but 1, 1 we get. This is a carry. 1, 1 is 0, 1. 1, 1, 1 nothing but 1, 1 we get. This is the number we get. Because you see that when you add 1 plus 1, what do you get? 1, 0 we are getting. This goes as carry. And if triple 1 is there, what do you get? 1, 1 we are getting. That's why 1 is carry and 1 remains there. In this video, we will see about logic gates. We have different logic gates are there. That is, first gate is OR gate, or AND gate, NOT gate, and NOR, NAND, and XOR gate. Different gates we have. So these are having some input and they give a logical decision in the output. So for logical decision only they use OR gate. For example, you can take first about OR gate. OR gate we can take any number of inputs, but mainly minimum we have 2 inputs. So A and B are inputs and output is A plus B they are mentioning. Here what is the truth table of OR gate means if any one of the input is 1 then definitely output is 1. If both are 0 then only it become 0 only. Where we use this type of logic while programming. Suppose if you want to check about a qualification of a person to join in MBBS. The person who is passed the intermediate board exam or the person who passed the CBSE exam. Both are qualified now. Suppose one person is there who is passed the intermediate board exam but not writing CBSE exam. He will be qualified. And the other person who write and CBSE exam qualified and board exam is not qualified, that he also qualified for to join in MBBS. And the person who studied in both and 2 years intermediate exam, intermediate and 2 years CBSE, both he studied, then he also qualified. But the person who not qualified intermediate board exam and not CBSE exam, then he is not qualified. That means here either one is true or both are true means then you get true. If both is false then you get output is false. So 0 0 means both are false. He is not qualified any exam, then he is not qualified for joining MBBS. And one he qualified, other he is not qualified, then also he can join. And first one qualified, second one not qualified, he can join. Both qualified also he can join. So only 0 0 means you get 0, remaining all cases you get 1. And analog circuit you see. And to work this bulb, you can close any one of the switch. Suppose if both are open, it won't work. Why? Because current is not flowing. Suppose if you close this and current is flowing like this, it works. If you close this, current flowing like this, it works. Even both closes and current flows in both ways and bulb works. Whether current is flowing or not, that only we are checking here. This is about analog circuit of OR gate. OR gate means either this or that. Any one is true, output is true. Even both are true, that also true only. When both is false, then you can say output is false, nothing but 0. This is about analog circuit. Now we'll see about digital circuit. So here with the help of two diodes, they design digital circuit of OR gate, and A and B are inputs and A plus B is output. Here there is a load resistance RL is there. So think that 0 means we are not applying any potential. 1 means you can apply think like a 5 volt potential we are applied. 5 volt potential we are applied. You can think like that. Then in that case, suppose first think 0 and 0 given. 0 and 0 given. Then what is the output? And here potential is 0. Here also potential 0. Here grounded. This also 0. Then no current is flowing and we won't get output. Output also 0 we get. Suppose here 1 and 0. What is 1? 1 means 5 volt plus 5 volt. Plus 5 volt means this diode become forward bias because here 5 volt, here 0. So it is forward bias. Some current is flowing through the load resistance. Then you get some output. So here 1 means output. What you get? 1 we are getting. Same thing happen here 1 and there 0 also. Then also this is conducted. This diode is conducted. Then output we are getting 1. If both are 1, so this also 1 and this also 1. Plus 5 volt plus 5 volt. Both diodes are forward. Then you get output current and output voltage we are getting that also 1. Except 0 0 remaining all cases these two diodes are in forward bias. Because of that these diodes are forward bias. Because of that some current is flowing through the load resistance. Across that we get some output. This is the digital circuit of OR gate. And this is the circuit symbol of OR gate. Whenever you use and like a transistor we have circuit symbol, for diode also, and similarly we have for OR gate circuit symbol like this and a little bit curved surface you have to take here, curved line. Input is A and B. Of course you can take any number of inputs, but generally they are using two inputs only, A and B. Output is A plus B. And input and output digital waveforms of OR gate. We know what is digital waveform, square waveforms they give. So first of all, here what we take, A is 0 0 1 1 is there. How A is changing? 0 0 1 1. That's why low low, high and high. So you can say this is a low low, high and high. To separate this, I draw a dotted line, but actually it is not drawn. So it will be like this. 0 0 1 1. You see 0 0 1 1. What about B? 0 1 0 1. So that's why B is 0 1 0 1. Low high, low and high. And what you get output? You see output is 0 1 1 1. Low value and high high and high we are getting. So that's why first you get low value, then you get high and continuous high and high value we are getting. This is about input and output digital waveforms of digital waves of OR gate. And some operations we'll see. Boolean algebra for OR gate we'll see. 0 plus 0, here only we discuss. 0 0, what do you get? 0 only. 0 1 1 1 0 1 1 plus 1 1 only we get. Like this we can write. Now A plus 0, something we don't know this value A, and plus 0 is there. What do you get? A only. That means you see A plus 0 is equal to, suppose if A is 0, what do you get? 0 plus 0, you get getting 0. If A is 1, 1 plus 0, you get 1. Means what is the A value? That only we are getting. That's why A plus 0, what do you get? A only we get. That is about A plus 0 is equal to A. A plus 0 is equal to A, because you see A plus 0, if A is 0, you get 0. If A is 1, you get 1. That's why A plus 0 is equal to A, plus represent here OR gate, not addition like, it is like OR gate, plus means. And what about A plus 1? A plus 1, what do you get? If A is 0, 0 plus 1 is equal to 1 we get. If A is 1, 1 plus 1 is equal to 1 you get. So whatever the A value, it doesn't depend upon A, and always you are getting 1 only. So A plus 1 is equal to 1 we get. Okay. Now A plus A bar. A bar means reverse of that. So A plus A bar. If A is equal to 1, what is A bar? 0. That what you get? 1 only. Why? Because 1 plus 0 is 1 in OR gate. And A plus A, or in this case only can take another case. If A is 0, what do you get? 0 plus 1 is equal to 1. Always we are getting 1 here. And now let's check. A plus A, what do you get? If A is 0 and this also 0, 0 plus 0 you get 0. So what is the A value? That only we get. If A is 1, 1 plus 1 you get 1. So what is the A value? That only we get. Here also. Now let's see about next gate, that is AND gate. AND gate represent with dot, input A and B, and this is a dot. What is the output means? If both are ones, then only we get 1. Both are true, then only get true. Remaining all cases false only. So false, false, false. False and true, false. True and false, false. True and true, then only true. Where we take this type of logic means, for example, and the same case, to join MBBS, here 1, you should pass IPE and you should qualify NEET. Both he has to qualify. If anyone is fail and he is not able to join, he is not eligible to. If any IPE he has to pass, and NEET also he has to pass. And if anyone is fail, he is not qualified to join in MBBS. Suppose for a person and who qualified both, suppose first 0 0 you can take. What 0 0 represent? 0 0. Not passed in IPE, not getting in NEET, so rank. So he is not qualified. And second, not passed IPE, but he qualified in NEET, not possible. Yes, he passed IPE but not qualified in NEET, so then not possible. Now he passed in IPE and he qualified in NEET also, then he is able to join in NEET, in MBBS. Same logic here for analog circuit. You see, when both switches are closed, then only this bulb works. If any one open or both are open, it won't work. This is an analog circuit. Okay, this relation, this truth table satisfy this analog circuit. You see that. Now about a digital circuit. Digital circuit, same as OR gate only, but diodes are reverse connected. Here you see diodes, and the diodes are reverse, and here one more power supply here connected. Here there is no power supply. Here the additional power supply is connected here. Suppose when first you can take 0 0, here 0 0 you can take 0 and 0. Then what happen? And here positive, this positive connected to P type, it become forward bias. Then what happen? Current flowing like this. It won't use this resistance because this high resistance is easy path. Forward bias means diode resistance is very less. That's why total current is flowing like this. No current flows in this way, so we won't get any output. So 0 0 means you get output is 0. Suppose 0 1 or 1 0, what happen? One is reverse bias, other is forward bias. In these two diodes, at least one is forward bias, then what happen? It becomes short circuit and no current flowing through this. So output we are getting 0. Suppose if you take both are 1s here, both are 1 means both have high potential here. Then what happen? This become reverse bias and this also reverse bias. They offer infinite resistance. It won't allow current. Then only the chance to flow current from this potential is through load resistance. Then we get output as 1. So 0 0 or any one is 0, what happened? That diode becomes a forward bias. Because of forward bias, less resistance is there. Then the current flows in this path or in this path only. It won't use RL. But if both are reverse bias, what happen? Infinite resistance, then there is no chance to flow current in this direction. Definitely it flows like this. Then you get here output. That is about digital circuit. This is a circuit symbol of AND gate. OR gate, this you see it is a curved line. Here you get a flat line like this we get. So generally AND gate number of inputs are there, but to discuss general concept we are taking 2 inputs and 1 output, that is represented with dot. There it represented with plus, here dot. And input and output waveforms. So 0 0 1 1 0 1 0 1. So what you get output? When 1 and 1 is there, then only get 1. Remaining all zeros only. So 1 and 1 1 1 and 1 is there 1, and remaining all zeros only we get. This is the input waveforms, these two, and this is the output waveform. Now Boolean algebra for AND gate we'll see. So 0 0 means 0, 0 1 means 0, 1 0 means 0, 1 1 means 1 only we get. So here A dot 0, what you get? Always 0 only. Why? Because in one of that is 0, then you get 0 only. Okay. And now A dot 1, A dot 1, this of course this is 1. If A also 1, then you get 1. If A is 0, you get 0. That means what is the A value? That only we are getting now. That's why you can take it as A here. And A dot A bar. If A is 1, A bar is 0, then you get 0. Because any 1 is 0, you get 0. That's why. If here this is 0, then this is 1, then 1 is 0. Now that's why you get 0 here. What is dot means? If any 1 is 0, you get output 0. If A is 1, this must be 0, then you get 0. If A is 0, then definitely get 0 because dot any 1 is 0 0. And A dot A. If A is 0, 0 dot 0, you get 0. If A is 1, 1 dot 1 is 1. So you get A only. What is A value? That only we get. So that's why A dot A is A we get. NOT gate. NOT gate truth table. If you say false, that you get true, and true means you get false. Reverse we are getting A represent output represented with A bar. Only one input and one output is there. So analog circuit, you see that here switch is closed, bulb is not working. Switch open, bulb works. This concept already we discussed in the NOT gate concept. And this is the digital circuit for NOT gate. When input current is 0, output is maximum, we are getting VCC, we get outside VCC. And input some current, suitable current if you are sending, output we are getting 0. So this we discuss a NOT gate as a transistor used as a NOT gate concept. So here we have one input and one output. The circuit symbol is like a diode only. Instead of bar, they put around a small sphere, like a small circle. A bar, 0 means 1, 1 means 0, you get. So in input and output, what you get? Input and output. Here you get 0 means 1, 1 means 0, we get. 0 means 1, 1 means 0, 0 we get. What is A bar, whole bar, reverse of reverse, what you get? Same only we get. And 1 bar is 0, 0 bar is 1 we get. This is about NOT gate, reverse. Next gate is NOR gate. NOR gate nothing but opposite of OR. You can think like a OR plus NOT. So this is the truth table of a NOR gate, actually A and B. And to understand easily, I'll take first OR gate. What is OR gate output? Any one is 0, that is 0, remaining all ones only. But what is NOR? Reverse of OR, that is A plus B here, A plus B whole bar. That's what you get here. 0 means 1, 1 means 0 you are getting. So what do you say? If all are 0, then you get 1. Remaining all cases 0 we get. That is about NOR gate. And NOR gate, how to write means they took one OR gate. You know, this is the symbol of OR gate, and they add with a NOT gate. So OR gate plus NOT gate combinedly what we call NOR gate. The circuit symbol of NOR gate is like this. This is the OR gate only, but here they put a small circle here. It is about output. NOR gate, how we are getting? AB means, here you see, AB means you get A plus B whole bar. A plus B means R, whole bar means NOR gate. And waveforms also you get reverse, you see. And there in OR gate, what you get? OR gate, you see 0, 1, 1, 1. Here what you get? Here 1, remaining 3 zeros you should get. See that? Here 1, remaining 3, we are getting zeros. Suppose if two inputs of NOR gate is joined, two inputs, both are joined as a single input, then what you get output? Exactly opposite of this you get. Here 0 means you get 1, 1 means you get 0. How we know means, you see that here for example, and the NOR gate, what is the output we'll see. If both inputs, if A is equal to 0, means here 0, here 0, 0, 0, 0, 0 we are applying. 0, 0 we are applying, what you get? Here 1 we are getting. That means if you are applying 0, we are getting 1 here. Suppose here you can apply 1, then here also 1, here also 1, both are joined together. That is both are 1 only. Then both are 1, what you get? 1 and 1, what you get? 0 we are getting. So you get output 0. That means input is 0, output 1. Input is 1 means output is 0. This will be here like a NOT gate. That means NOR gate, two inputs are short circuit, two inputs are joined. It behaves like a NOT gate. Now let's see about other gate, that is about NAND gate. NOT plus AND plus NOT, that what we call NAND gate. It is exactly opposite of AND gate. What is AND gate truth table? 0, 0, 0, 1, 1, 0. All are 0 only except 1, 1. 1, 1 means 1, remaining all zeros. But here reverse, 1, 1 is 0, remaining all ones. That is A dot B whole bar. This what we call AND plus NOT NAND gate. And input and output digital waveforms of this NAND gate you see. And here this is input and two inputs. And what is output? Exactly opposite of AND gate. You see 1, 1, 1, 0. That's why 1, 1, 1 and last one 0. Up, up, up and down here. That is about NAND gate waveform. See that and here how they write AND gate plus NOT gate. A dot B and NOT gate is there, A dot B whole bar. This is the circuit symbol. What is the difference between NOR gate and NAND gate? Here that is a curved line is there. Here flat line is there. Like OR gate and AND gate. Here for AND gate flat line. That's why you get NAND gate like this. Here a small circle we get that represent NAND gate. This is AND, this part is AND, and this is a NAND. Here a small circle is added. NAND gate. Similarly, if two inputs are joined together, then how it behaves like means it behaves like a NOT gate only. Suppose NAND gate, suppose here 0 is there. 0, 0 means for AND gate we are getting 0, but NAND gate we are getting 1. Opposite, no? So that's why 0 means we are getting 1, and 1 means what you get? 1, 1 for AND gate is 1, but NAND gate reverse, so you get 0 here. So even NAND gate also, NAND gate or NOT gate, both inputs are joined together, then output behaves like a NOT gate. Total circuit behaves like a NOT gate. NAND gate used as NOT gate by joining two inputs. This is about NAND gate. Now other gate is there, XOR gate, exclusive OR gate. Exclusive OR gate. So in this case gate, what is the truth table means? 0, 0 we get 0, 1, 1 also we get 0. When only one is there, nothing but odd number of ones is there, then you get 1. Even number of zeros or even number of ones means you get 0 only. And the circuit symbol for this is like this, like OR gate only, but they draw additional curved line here. For OR gate you see, this is a circuit symbol. One more line they draw here parallel to that. That is here what we call XOR gate. And XOR gate like OR gate only A plus B, but they show here a round symbol. This is XOR gate symbol. For OR gate it is plus. For OR gate they represent plus, for AND gate dot, for NOT gate whole bar we are getting, and for NOR gate that plus whole bar. NAND gate means dot whole bar, and XOR gate means plus, and like this make it round symbols. And what is the output of XOR gate means A dot B bar plus A bar dot B. So to draw this circuit, you see here what we are doing. First what we need, A dot dot means AND gate, A connected to AND gate, but directly not connected with B, and bar is there, so that's why B and AND gate is there, that become B bar. B after connecting NOT gate, this is NOT gate, not AND gate, NOT gate, and it become B bar. Now and we are applying AND gate between A and B bar, that what you get, A dot B bar. And similarly here, and other case, A bar dot B. That's why for A we are connecting a NOT gate, that become A bar, and directly B is connected, so only B is there. So what you get after applying AND gate, dot we are getting. So this is A dot, not B bar, this is not B bar, that is only B. This is only B, no B bar. These two both are joined with OR gate, that's why you get in between plus. So plus is there, that's why OR gate, dot is there, that's why AND gate, and here also dot is there, that's why AND gate we are using, and B bar is there, that's why we get one NOT gate, and A bar is there, that's why we get another NOT gate. This is the total circuit diagram of a NOR gate, that simply you can represent like this. And output waveforms, what you get, 0, 0 means 0, 0, 0 means 0, and 1, 1 also 0, remaining all ones. 0, 0 means 0, and 1, 1 also 0, remaining both is 1. What is the output waveform of XOR gate? Odd number of ones is there, then you get 1, remaining cases you get 0. That is about XOR gate.